open source virtualization clusters, and hungry breadboards. All that and more this time on Hack 5. This episode of Hack 5 is brought to you by Domain.com. Hello and welcome to this episode of Hack 5. My name is Shannon Morse.
I'm Darren Kitchen.
And this is your weekly dose of Technolust.
Very exciting show indeed. We have many announcements. This is the actual episode after the warehouse party.
Are we announcing the announcement?
The announcement of the announcement,
yes.
Now that everything is finalized and legit
Righteous
stuff.
dude.
So I heard that you'd been doing a little show with our friend Patrick Norton for a while called Techzilla.
Techzilla,
And
yes.
that ad has run its course.
It has.
But I hear that
sadly.
there's something new coming.
Yes, there is. It's called Tech Thing. Dun, 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 na, 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 na.
Is that the theme song? That is, in fact, the theme song.
I don't know yet.
Alert, I don't know. We'll
We
find
haven't
out
gotten
soon.
the theme song back yet. I've been keeping track of my emails, waiting for that theme song.
But all of the other stuff is, I'm super excited for that.
Me too. So Tech Thing is
very
going to be
soon.
the new revision, the new generation of Techzilla. We're going to bring it back to the old school sense of Techzilla, where we answer your viewer questions, but it's for a broad audience. So
This
it's
is so
not going to be
exciting.
as crazy as Hack 5 is.
You know, it's
going to be fun.
Oh yeah, unlike Hack 5, it's going to be fun. No, I'm excited because, for the longest time that has been our sister show. And I got very sad with the Rev 3 announcement of the getting rid of all of the internal programming and becoming a thing. And so now I'm like, yay, we have our sister back.
Yay!
Our sister is Patrick Norton.
Oh, that's so creepy.
And you. That's weird.
So
Anyway.
what were the other announcements?
Oh, right.
Sir?
Bringing back ThreatWire,
Yes.
Metasploit Minute, Pineapple University, Let's Code, and a bunch of other stuff.
That's awesome.
We'll have more
I'm
details on
excited
that
for
here
all
real
these
soon.
new shows
Yes.
and all the ones that we are bringing back.
Me too, and a lot of our friends are going to be joining us here at the Hack 5 warehouse as we kind of like do a little art collective thing, and it's fun. So keeping it old school podcast, true to the heart of the nature of it, keeping it open source and all the good
How does that
stuff.
work? You mean like creators own your own content?
Let's not go
What?
off on a tirade. Shannon, we're doing Hack 5. We're very excited because I know that you have been diving deep into the Arduino stuff.
I have,
I saw some blinking lights in her office earlier, so I'm excited about
My light, it
this.
blinks.
That's right. And you too at home can tweet @Snubs and make her light blink.
Oh, well, I guess I could set it up so that, a tweet makes it blink.
There you go, Internet of Thingies.
Yeah.
In fact, that harkens back to like episode 1 of Hack 5 where we made your lights turn on and off.
Yeah, I'm so excited about it. So it's super simple, but it gives you a great example of how breadboards work. So today I'm going to be doing an intro to breadboards.
I love that you're building foundation of that stuff because we've been working on some Pineapple HDK stuff, and I know some viewers at home are building robots for that, and
Yes.
it's going to be exciting to kind of like tie all that together.
Awesome.
So we're
I
really
can't
working
wait.
in some kind of similar infrastructure there.
And you're doing some fun stuff too.
Yeah, speaking of infrastructure, I'm tackling some virtualization stuff today. It's been a while since we looked at building a high-performance virtualization cluster. In fact, one of the nodes is behind me. We did this a couple years ago. It is. It's spinning and
Yay.
everything. We did this a couple of years ago with Proxmox VE, and things have changed. So we're going to take a look at all the new hotnesses and what we will be bringing to the server rack. And thank you to the guy at the warehouse party that offered to donate his server rack.
That's awesome.
Between the 600 megabit
that
lines that we're
Josh, maybe?
getting and all of that other stuff, we're going to be having some fun stuff here. In fact, stay tuned to the end. We've got some LAN party announcements. So
Yay!
stay tuned for fun things there.
Oh, and by the way, yes, this is my natural hair. Somebody once commented and said that they hated the curls and the perm and I should not do a perm. But guess what? This is natural. It's raining outside. I ain't straightening my hair.
Oh, that's right. It's the Bay Area Hella Storm, as it were. Hashtag Hella
The
Storm.
Hella Storm.
Yes.
So, yes, that's me.
Okay. Well, hey, you stay curly,
Okay.
and I'm going to rock over to our B set. This is so exciting. We haven't had a second set since the Hack House. I'm going to steal this. And we're going to talk a little bit about virtualization.
Yay!
So that machine that you saw on the wall over there is, in fact, running our first node, or it will be our first node. The rest of them will probably go in a regular rack. right? But it's really exciting to get back to this because it has been a while since we built a high-performance virtualization cluster. And when we did that, we did it with Proxmox VE. It's a hypervisor. It's similar to VMware's vSphere. Microsoft's got their Windows hypervisor. There's Citrix Zen server. And what I liked about Proxmox is that it's mostly just a beautiful front end for two really cool technologies, KVM and OpenVZ. And it's been a while since I last looked at Proxmox, and since then, their model has changed a little bit. Now there's an additional subscription service to get access to the stable branch. It's still GPL, so you can still find all of the code in their Git repository. It's kind of a pain now, but thankfully, their community edition starts at just €4. I still think they're doing really cool stuff. But it brought me to wondering, okay, what other alternatives are there? And so, since we're going to be bringing in a lot of servers here to the Hak5 warehouse, given that we are about to be receiving 600 megabits of bandwidth and 52 static IP addresses, long story short, it was the only way that we were going to get decent bandwidth in here, so we kind of had to swallow a monster behemoth of bandwidth, but that's okay because we're going to fill out ye old server rack, and the most efficient way to do that is with virtualization. I mean, virtual machines just do a better job of utilizing resources. They make better, they just do better with things like storage and scalability, and I love backups with just like snapshots. It makes life so much easier. And so, recapping from last time when we went down this road of virtualization, I was basically keen on two technologies that Proxmox does a very good job of managing, and that is KVM, which is a kernel-based virtual machine, and it basically turns the Linux kernel into a hypervisor. It's been around since 2007. This thing is awesome. It utilizes the virtualization extensions built into most modern computer hardware, like Intel's VTX or AMD's AMD-V. And anyway, it's great for running multiple OSs. Like you can have a server, and sure, under the hood, there's like Linux and the kernel, Linux kernel and the KVM, but on top of that, you could have OS X, and you could have FreeBSD, and you could have Linux and Windows and all of that other stuff, which will be really cool because we're going to need that in our infrastructure. The other thing that we're going to want is OpenVZ. And it's kind of like on the flip side of virtualization technology. I'm really keen on it because it's more of a virtualized environment rather than a proper hypervisor. What that means is you can't run OS X or OS X or whatever you want to call it, or Windows or FreeBSD on top of it. It's just straight Linux. But you know what? For shells, for most of the VPSs and things that I want to do, and the things that we're going to bring you in doing, since we're going to have all those IP addresses, Linux is going to be just fine for that. And it also, on the plus side, means that OpenVZ, the virtual machines, they run on top of that same Linux kernel, so you don't have all of the overhead of managing all of those different systems, and overall the whole thing is just zippy. Unlike KVM, where you have to allocate like different chunks of memory to each VM, like this Windows Server 2008 box gets 4 gigs of RAM, and that OS X box gets 2 gigs of RAM or whatever, you can actually kind of share the memory across all of those OpenVZ instances, which is pretty cool. Either way, both OpenVZ and KVM have their pros and cons, but really when paired together, I feel like they make an awesome team, and it's why I really loved Proxmox VE. And really it just adds a nice front-end management GUI of awesomeness. So, looking for alternatives, the first two that I am interested in, and trust me, there's plenty, but the first two alternatives that I came across that look really good are Overt and OpenNode. Now, Overt is what I'm kind of running here, and that's what I'm going to be looking at today. It is pretty cool in that it can be installed as an all-in-one hypervisor, or you can install it on your distro of choice. So if you're running Fedora Core, or Red Hat, or CentOS, or Gentoo, or Debian, you can just have like an all-in-one installation that gets all the dependencies and everything you want all set up for you, which is really cool. And if you want to test drive it, and this is where the other one didn't quite pan out. You can actually just boot off of a USB in this case and try it out. And their live version is based on CentOS, and it just makes it really easy to dive in. So it feels really polished. I'll go through it. So I've basically just booted into here, and the first thing you see is you get like a pop-up saying, hey, we're going to do the all-in-one install. You want automatic, or you want to pick and choose all this stuff? And since this is just as a demo, I'm like, do automatic. And you can see here it actually starts the engine, which is the hypervisor and all of that. It starts the the disk management, starts the HTTP service. I've got my NFS started. I didn't have to think about anything. All of that was already set up, and really all I have to do now is hit OK and pull up a browser and hit up localhost. So I'm going to go to http:// yeah, there it is, localhost.localdomain. And of course, configure this for your environment. Come on. And I'm in offline mode, offline mode. And let's try just doing it this way. OK, so there's no place like 127.0.0.1. And in this case, I'm going to go to the administration portal. And yes, this is not a signed certificate, which is totally cool because it's my machine. So I know what I'm doing. Thank you, Firefox. We're going to add an exception. And now we can do this over SSL. Username is admin. And password is overt, O-V-I-R-T by default. So you can see here's your control panel, and you can actually see all of your different clusters, whether they be your different nodes of running your hypervisors or even your storage here. They've got plenty of templates, which makes it easy to deploy things like Windows and Linux servers. It's got plenty of storage options like NFS and iSCSI, even gcluster.fs. It even does USB pass-through, which is something I'm quite keen on. That's where you can basically just take, like, say, I don't know, a wireless adapter and then plug it into the machine and say, hey, that device with this vendor ID and product ID, send it to that VM, which is pretty cool. And you can manage all of this just from this really pretty GUI. If you've ever played with other hypervisors like VMware, this should feel pretty familiar, and it makes it really easy to deploy additional nodes to our cluster throughout our data center, or we can play with our networking settings. It's got all of that stuff built in. So deploying virtual machines is as easy as just choosing a template, or just doing new VM and walking through a wizard. I haven't gotten too far into this just yet. I'm still just dabbling, but I must say, so far everything seems quite polished. And it seems to fit the bill as far as what I'm looking for, which is just like a nice open source thing to kind of get out of the way and let KVM and OpenVZ shine. The other one that I'm going to be checking out here is OpenNode, which seems very similar. It has its own management interface that is its own VM, and then it also has a text-based one, which you can always get to over SSH, and then it's done like, I don't know if it's with ncurses or what, but it's like a pretty GUI. It's a TUI. It's a text user interface, but it's all graphical and pretty. And anyway, that seems pretty cool. I'm going to be checking that out. And I wanted to hear what your thoughts are as we get into the beginnings of this project. There's still a lot to do here. We've got to figure out what we're going to be doing about storage, and we've got to set up our cluster and all of our nodes and the network, and it's just going to be awesome. So that's my first take on Overt. I'll also be looking at OpenNode, and I'd love to hear what you guys think. So hit us up, feedback@hack5.org, and hey, maybe when we get all this together, we'll even start offering shells and VPSs and good stuff like that. But until then, we're going to take a quick break, and I will see you in a bit. Doesn't matter whether you're interested in running virtual machines on your bare metal or bare metal on your virtual machines. I have no idea how that would work, but when that killer idea hits, you're going to need to snag yourself a domain name and web hosting fast. Maybe you're the one that's going to figure out how to run bare metal on a virtual machine. And you'll head over to domain.com and you'll find that their quick domain discovery system and their easy checkout process will have your website up and running in no time. And I've told you guys before that I love domain.com mainly. They're affordable, they're reliable, they're easy to use, but mostly because they have an awesome active media presence on social media where you can tweet them at domain.com and see why they're just like a fun place to do business. And the guys over at domain.com, oh, those guys, they want to hook you up. They're huge fans of Hack5, and so they have this special coupon code. It's called Hack5. I know it's really easy to remember. So when you're at checkout, to save yourself an extra 15% off. And when you think domain names, think domain.com.
It's time for the trivia question of the week. Last week's trivia question was, which programming language was designed for managing data held in a relational database management system? It was created by Chamberlain and Boyce at IBM in the early 1970s. And the answer is SQL, or SQL. Now this week's trivia question is, what widely used and influential programming language was developed by Dennis Ritchie and Ken Thompson at AT&T Bell Labs in the early 1970s? Answer that over at hack5.org/trivia for your chance to win some awesome Hack5 goodies. With all the excitement over Arduinos and microcontrollers, I decided I might want to figure out all the other different components that are included with building prototypes. That includes breadboards and LEDs and resistors and motors and everything else that's included in a little box of shiny awesomeness. So the first thing that I wanted to discuss is a breadboard, because there's not really a point in trying to build your own prototype if you don't understand why something works in the first place. So it's really nice to get an introduction. So first off, we're talking about these breadboards, aka protoboards. So the reason why it's called a protoboard is because people build prototypes on them. But the other reason that they call them breadboards is because literally back in the day, electronic engineers, they would actually take breadboards, the literal breadboards from a kitchen, and they would wire circuitry around them and into them. So that's why they call them breadboards. But nowadays we have these beautiful, super shiny and lovely little pieces of plastic that have a whole bunch of pins on them and a whole bunch of metal on the inside. So on the inside of a breadboard, you have a whole bunch of separate nickel-silver clips. They are conductive, they just sit inside the ABS plastic, and they're all insulated, so all of them are separate except for if they're in a separate region. Now, regions are all these different holes. Those are divided into little strips. So first off, we have a bus strip. If we look closely at this really tall one that I have here that goes from line 1 all the way down to line 64, and it has A, B, C, D, E, F, G, H, I, J, so a whole bunch of different rows going down. We also have a plus and minus and a plus and minus on both sides. Now these are called the bus strips. So these basically provide any kind of power to a circuit. Now you can have one power and one ground. So the power would be the plus and the ground would be the negative. But these sides aren't connected. There's only one metal strip going all the way down the plus side and one metal strip going all the way down the negative side. And those two don't ever touch, so they're completely separated from each other. So first off, you have those bus strips, which are the ones just on both sides. And then next you have this one in the middle, and those are called socket strips. So these are where you're going to hold all those different components, whether those are your fans or your motors or your buttons or your wires or your resistors. Pretty much whatever you want, you can hold into the middle of these and all those different pins. And I have a few hundred pins on here that I can actually use because I can use everything from A to J and from column 1 all the way down to column 64. Now each of these columns are electrically combined to each other. They're connected with all sorts of metal clips. Now if we look a little bit closer on here, and I'll get it down here for you, each of the clips are connected from one side to the other. So they're connected from A to E and then from F to J. They are not connected from 1 to 2 or from 25 down to 30 or so on and so forth. Each one has a metal clip on the inside, and each of the metal clips can hold a wire inside of it. So that way, you don't have to use any sort of soldering, which is really nice because for prototypes, you might want to take it apart. You might need to fix something, something like that. Now, you also might have noticed that on my breadboard I have this little middle rivet where there aren't any pins. There's nothing, there's no metal. This is basically just a rivet that cuts the breadboard in half. So that way you have two separate sides that you can use all sorts of different circuitry on. And that circuitry is not going to touch, it's not going to be connected, it won't short itself out because it's on two separate sides. So I guess you could consider it kind of two separate breadboard halves. Now lastly, they do have notches on the sides too. For example, this large one that I have has 3 notches on the top, bottom, and in the middle. And then it also has notches on the sides. Those can be used to connect this breadboard to another breadboard of the same size. So if you run out of pins, you don't have to worry, you don't have to take apart your prototype. You can just grab another breadboard, snap it on, and then you'll have extra additional pins that you can use. Now for my prototype. So the one that I'm using here has a whole bunch of different connections, a whole bunch of additional pieces to it. So first off, we have the Arduino, of course, and then we also have the LED, which is right here. And third, we have a whole bunch of wires, the 1, 2, and 3 wires. Next we have a resistor, which is found right there, and a push button right here. And last is the breadboard. So nice and simple. So first off, the Arduino, that's your microcontroller. The breadboard is going to be used for additional circuitry for all your different components. And then we have all these different wires. So the wires, you might look at those and be like, why did she use green, blue, and yellow? I don't understand why those different colors matter. Well, they don't really matter if you're just doing a really simple prototype like this, but when you get a really, really big prototype going and you want to separate things depending on their power, depending on if they're 3.3 volts or 5 volts, or if they're ground, or if they're connected to a specific piece of component, you might want to use a specific color in that matter. Now these ones, I just have them all set up to go from one spot to another. They don't really matter at this moment. Green's going from one place to another, blue the same, yellow the same. So I didn't really set them up in any correct form or fashion. But each of these, I should mention, are 20 to 22 gauge. Now I chose that size because that's the size that will fit into these pins. Now you know. Now next up we have resistors. So resistors, they're kind of complicated. There's a little bit of math that goes into resistance because resistance has this whole electricity math thing that goes on with them, with ohms, I believe they're called. So basically, just remember for this segment here, they all have electric resistance that doesn't change. And they all limit the flow of electricity from one end to another depending on what specific thing that you're working on for your prototype. I'll do a whole bunch more information on a future segment, but for now, that's all you need to really know. Now, let's move on to our code for this example. So for my code for this example, I basically wanted my Arduino to blink every time I press down a button. So for this code, and this is my example number 2, this is just a little comment up the top, I want to turn on the LED while the button is pressed. If the button is not pressed, I want to turn off the LED, so it's completely off until I actually put pressure on the button and it creates a constant flow of electricity to the LED. So first off, we have a constant int, and this first one is the LED, and this is describing the LED as being in pin 13, so that is on this physically on the Arduino board. Next up we have the button, so I named this second int button, and this one is going to be physically button 7, or pin 7, excuse me. And lastly here we have int value equals 0, so this val is the state of the pin, so that is basically the starting point for the pin itself. Now when you go down a little bit further, this is where you get into some more interesting stuff. Now you might remember last week when I mentioned inputs and outputs. So an input is going to be anything that causes an event, and output is going to be what happens after that event. So first off we have the LED is going to be triggered by something, so it's going to be the output. The button is going to be what triggers something, so it's going to be the input. Scrolling down a little bit further and we have our loop. So first off we start with the val. Val equals digital read. So this basically means that the Arduino is going to be reading something from the code, which in this case is going to be button. So it's going to be reading whatever the button is doing. And depending on whatever code I write is going to tell the LED what to do, since that's the output. So next up I have my if-else statement. So this is my little if-else down here. First off we have the value equals high, and last week we mentioned that high equals on. Digital write is going to be LED equals high, so now if the button is pressed, it's going to turn on the LED to be high or on. Else, digital write LED equals low. So else, if the button is not pressed, it's going to tell it to be off. And then we just close our statement with the nice little curly brackets at the bottom. Now what I do after this is I hit verify, and then I can hit upload, and it should upload within a couple of seconds to my Arduino. Now once you have that completed, you should be able to do this. So I have my LED right here, my button's right here on the breadboard, you'll notice. And I press it, and the LED goes off. It works! Yay! So I'm going to show you a couple of specific things on here first of all. Over here I have my green pin, my green wire plugged into the 5 volts. Next I have a ground pin, my ground wire is going into, the blue wire is going to ground, and that's being fed over to my resistor. The resistor is being fed from the blue pin over to the button and to the yellow wire. The yellow wire is going to bring whatever I tell the button to do, so in this case pressing it, over to pin 7, And pin 7 is going to tell the LED what to actually do. And lastly, of course, the green is the 5 volts, and that's going to give me some kind of power for the button to actually do something. So that's about it, and I hope that kind of explained what a breadboard is, how it works, and how you can actually set up some kind of code combination with your Arduino and breadboard to make something happen. It's kind of cool, it's very simple, I know, but it's a good starting point for anybody who has never really used an Arduino before. Now I hope this helped you actually. If you want to, you can email me feedback@hack5.org with your comments or suggestions and let me know what you want to see me build in the future. I'll be back next week with more Arduinos. Stay tuned.
That just about wraps up this week's episode of Hack 5, but before we get going, I'm very excited.
For what?
Shannon, you like yourself some LAN games?
I love LAN games.
Oh, well.
With some grits.
Just like Mom used to make them.
Delicious LAN games.
If you hadn't noticed, it's about to be 2015.
Oh, man.
Which means
I'm old.
There's that, and also Hack 5 is, because Hack 5 was born in 2005.
Oh my gosh, Hack 5 is going to be 10 years old.
So check this out. January 3rd, here at the warehouse, we're having an epic LAN. So bring your laptop, because it'll probably run it, because we're playing nothing that was made
Legend
after
of the Red
2005.
Dragon.
No, we're going to save LORD for the BBS. But
we're going to play Counter-Strike.
Counter-Strike, Unreal Tournament.
Deathmatch.
Yes, and Instagib. And all sorts of good stuff there. I guess UT 2003 falls under the category of was made before 2005. Mm-hmm. What else? Why am I forgetting Duke Nukem? Can't forget that one. Break out your DOS box. We're going to have a little LAN party action. So the thing is, you're going to want to sign up because we will fill this one, and we're going to have to cap it off and say sorry. But yeah, let's fill the switch, right? So head over to hak5.org/LAN party and sign up. It's going to be January 3rd. So bring your hangover, bring your laptop, bring
out your dad.
We can all the things. And that, bring out your dead video games. Actually, seriously, we're going to be passing around like the hard drive video games because they're all going to be old, and we don't have barely any bandwidth here. No. So all the details, hak5.org/LAN.
Awesome. So I guess I need to carry in
Quake
my tower.
3. That's what it is. Well, I prefer everybody to bring the laptop because it makes it easier. However,
my laptop
if you want to bring your pimpin' tower, if you've got some awesome water-cooled rig you want to show us with the aquarium bubbles and everything, that's cool.
Halo.
Bring it on by. Halo. Paul's requesting Halo. There have been at the warehouse
I'm really
party,
good at Halo.
There were some requests for Mario Kart.
Oh, yes.
So we might break that out on the giant projector. So
yeah.
It should be fun. But I'm super excited about being able to do things like that. So hopefully when we get some bandwidth too, we'll bring back the virtual LAN parties as they were, where we can all, actually we could have everybody VPN, and there's no point in that, but we get people VPN in so that we could play. The point is
that it's awesome!
So that we could play traditional LAN party games over the internet.
And then
WAN party?
If you want to send us a comment or a suggestion or flame mail, you can email us feedback@hack5.org.
Yes, you can also comment on YouTube, and you can find from the YouTube page links to the ways to find the shop to support us directly, which is what we really appreciate you guys making this happen with your dollar and all of that. HAKshop.com, hack5.org/follow, feedback@hack5.org, all of those good things. And stay tuned because I hear there's going to be a thing.
Yes.
It's going to be a tech thing.
So you ready for the tech thing?
You ready for the tech thing?
Okay, ain't nothing but a tech thing.
Until then, I'm Darren Kitchen.
I'm Shayna Morse.
Trust the Technolust.
Trust that Technolust!
What? Why is there a boot? Das Boot.
My microphone's getting caught.
Well, if you haven't noticed, it's about to be 2015.
Oh God, don't remind me.
It's very exciting.
I'm getting really old.
No, well, you already are. I mean, you can tell by this whole thing here.
I will kill you.
And that's when we reshoot the show.
Boot.
Oh, Shannon. No, we were talking about bootloaders.
Okay.
Do you smell your cat's feet?
Yes.